Okay guys, welcome to the April 6th edition of our class of weather. Just to give you a heads up right off the bat, this is probably going to be broken up into several smaller videos for this week just because there's actually a lot to cover, and also because my camera has been just cutting off for the heck of it for no reason, and so I am not going to try to do the whole thing in one long shot. So anyway, starting out with, we're going to be talking about severe weather this week to begin with, and so we're going to look at different parts. You're already familiar with all the elements of weather. That's what we've already talked about. So we're still going to be talking about insolation, temperature, air pressure, winds, precipitation, air masses, cold fronts, mid-latitude cyclones. All those exact same things we've been talking about are in play right now. Just a little more detail and specifics. So I'm going to be using a lot of vocabulary words, which are on your study guides that you can look up, but I'm going to show them to you as well right here at the front, so you can exactly see what the word is, how to spell it, and then when I'm showing diagrams, you'll know what I'm talking about, in case you can't hear what I'm saying. So here's our first list when we're talking about thunderstorms. Here we've got the updraft, a downdraft. Downdrafts will lead to gust fronts and possibly maybe what's called a microburst. We're going to talk about single cell, multi-cell, and squall line thunderstorms, among others, but that's what we're going to start with today. I'm going to move the camera down a little bit lower to make it easier for me to show the diagrams. So hang 10 while we do a little bit of that. Get a great shot. Now, the way I'm filming this, and this is just the way it's going to be working out, obviously I'm in selfie mode, and that means that any wording in the diagrams is going to be backwards. The most important part is going to be the actual pictures. You can look up all these diagrams in whatever textbook you guys are using. You can Google it, look in your lab book. There's plenty of places to see these diagrams, similar diagrams, some that may float your boat better than the one I'm showing you. So use your other resources as well to look at these, to help you learn. The more you look at it, the more you're going to understand it. So let's talk about those thunderstorms to begin with. Now we're going to start talking about a single cell because it is the most simplest of all the thunderstorms, and it's got all the basic parts that all thunderstorms do. So every single thunderstorm is going to be starting with an updraft. That is just the rising warm air, all right? And in a single cell or single cell storm, this rising air is mainly the result of convection. This is going to be your very typical late afternoon garden variety scattered thunderstorms that we see that occur in the summer, all right? When by afternoon, the ground's gotten warm and transfers to the greenhouse gases in the air, and they get warm and start to rise, start to form a cumulonimbus cloud. That is the updraft that goes on. Once the cloud's formed and rain happens, well, that rain, which is going to be higher up in the atmosphere, so its temperatures are much cooler up here, and so we know that cold air is going to sink, all right? Plus, when the rain is falling, it's literally going to drag down some of the air with it. So you have the downdraft, all right, that forms right here. Now, when that downdraft comes down to the ground, it obviously can't go through the ground. So it gets bent and deflected and flows out in all directions. This is what is known as the gust front, all right? And you feel this gust front. It's usually just, it's just a little breeze is what it is. It's just a little itty bitty breeze. You'll feel it just before a thunderstorm hits. Oftentimes it's that little breeze that kicks up. It's usually cool and often smells of rain. And that, that's your 1 minute warning to get inside before the big heavy rain hits. But as is the nature with these single cell thunderstorms, if you've got air blowing up and at the same time you've got air coming down, they're going to end up choking each other off. And pretty soon the uplift is squashed out and without uplift, the storm is going to die off. And so you go through stages of beginning, mature stage, all right, and then the dissipating stage. And your typical single cell thunderstorm lasts about 40 minutes, all right? That's about all, about 40 minutes from beginning to end right here, all right? But with most single cell thunderstorms that start up, they actually turn into multi-cell thunderstorms. Because what happens is that, there we are, all right, that gust front, all right, that starts off as the downdraft and then turns into a gust front, it can actually extend out for like 50 miles or so. And it's going to act just like a little itty bitty mini cold front. And it's going to cause other warm air to curve up right in front of it. Because again, remember, cooler air is going to be a little more dense. All right, so it's going to act like a little mini bulldozer. So this will be one of those little bobcat bulldozers instead of a big giant one. All right, and just, you know, when the warm air hits that cool air, it's going to be forced to rise, and you get more thunderstorms that are forming. So as this one is often dying down, this one, which may be a couple of miles away or, you know, something like this, is starting to form. And that in itself is also going to make a gust front, which can, of course, kick up many more. You have seen these before. Let me show you a photograph, especially in the summertime. Now, granted, if you're experiencing the thunderstorm at your location, all you see is one big giant cloud and lots of rain, all right? But you can see these on the horizon, all right, all the time. Look down to the south or over to the west, up to the north, and you'll see the silhouette and the profile of all these thunderstorms. So this is a picture of multiple thunderstorms. So there's one, I don't know if this was dying or just beginning. Here's one in the mature stage. Here's one that's definitely just beginning. All right, it hadn't quite reached the mature stage right here. So those are the multi-cell. And like I said, having just one little single cell is actually pretty rare. All right, usually that first single cell is going to start a chain reaction and you're going to end up with multiple ones. Now, another way we get thunderstorms, especially this time of year, here in the spring, are those that are associated with the mid-latitude cyclones, all right, and the cold fronts, okay? So these form what are known as the squall line, all right? So you can see the picture right up here toward the top, all right? So, I'll try to get this situated where I can work with it the same way, all right? So, here's your cold front, all right? And we know these cold fronts can last, you know, or be extremely long, like up to 600 miles long, all right? And if conditions are right, this big giant bulldozer is moving across the country, and it's, of course, kicking up warm air in front of it, all right? And those, if conditions are right, can form cumulonimbus clouds, which have your same updraft. You've got the downdraft here as well, but instead of one, this is also a type of multi-cell, but these are all lined up, and they can line up for, again, 600-mile chorus line in front of the cold front. Some of these may be directly in front of the cold front. Some of these may be 10 miles in front, 50 miles in front. In fact, you may often even have several squall lines in front, all right, working off the same philosophy of the updraft, the gust front of one line is starting up the one of another, all right? And oftentimes, you know, the individual thunderstorms that are in this squall line are also at different stages. One may be beginning, the one next to it may be, you know, falling apart, and then another one's right in the mature stage. But, you know, so there's slightly different intensities along the line of it, but there's usually some that are going really, really good. Let me show you the pic of what it looks like on radar, because this is where it's, we're easy to see. This is what we look for on radar when we are looking for this, and it's very easy to recognize. We have already looked at some of these. So here you go. All right. So you can see this is actually in front of the cold front. This is that linear formation we talked about, as opposed to a big splotch of clouds and rain that is associated with the warm front or with the low pressure center itself. So here you've got the very narrow line. Now this is just representing the rain. That's what radar looks at as the actual rainfall, not just clouds. But the red is the heaviest rain, and it's see a very narrow line. But this whole thing is a squall line. All right. The ones up here aren't quite as organized. They may not be quite in mature stage. And then I guess you can see there's some gaps here that are, you get different stages of development along this whole, but this is, going a very, several hundred miles long right here. All right. So that's the squall line types of thunderstorms that can form. All right. Now, the next type of thunderstorm, again, thunderstorms are thunderstorms, all right? It's just kind of the situations. But this is a special one, all right? This is called a supercell. And in order to be a supercell thunderstorm, you have to have what is called wind shear, which I will explain in just a minute. And this wind shear is going to lead to something called a mesocyclone. This mesocyclone is what makes a supercell a supercell. All right? If it doesn't have a mesocyclone, it's just a regular old normal thunderstorm. Okay? All right? So mesocyclone is what makes a supercell. All right? Now, these supercells, we will see, can last for hours. It can be one single storm, one single little giant thunderstorm, but it can last for hours on end. So it's very different from all the other regular little single cell and multi-cell and squall lines. Okay? And these guys are where you often will find the hail in those. Remember what hail is. We'll talk about it just a little bit. All right? And these are the thunderstorms that birth tornadoes. Right? Most supercells do not have a tornado in them. All right? They do not, but some of them do. All right? So, but this is where the really bad damage-causing tornadoes come from, and what the type of tornadoes we normally get around here. All right? These are from supercells. So, let me show you what makes a supercell different from just your regular thunderstorms, and why these are not, they're nasty. They're fascinating, but they're still nasty creatures. All right? So wind shear is the key. All right? What wind shear is, I'll show you a diagram in just a minute, but it's when you've got wind at different levels blowing at different speeds and in different directions. All right? So this is wind shear, as opposed to all the winds going in the same way, or like this. So you've got geostrophic winds, you've got surface winds, or you just got upper air, different layers of winds going in different directions. That is wind shear. All right? It's bad for airplanes. You cannot land an airplane in wind shear because as you're coming down from high up, you're dealing with the winds that are going this way, and then you get down lower and the one hits you, T-bones you from the other side. You can cause crashes. But what it does to air that's in between, so here is some silly putty, and it's going to represent just, kind of a layer of air between the closer to the surface winds and the little upper air winds. So these are moving in different directions. All right, so what happens when you do this? You notice what happened? All right, it rolled up. This is the same thing you do when you get bored and you take a pencil and you roll it like this. That's what makes it roll, is the fact that you're going in different directions, all right? That's what makes it roll. And this is your mesocyclone, all right? It is this horizontal layer of air in between the two different flowing directions of air that make, and it ends up rotating horizontally, just like this. So let me try to show you some diagrams of that as well, that hopefully will show this, all right? So I'm going to show you two different diagrams. All right, so here's your first one, all right? So right here we have the wind shear, okay? So top air is blowing this way, bottom air is blowing back this way. And so you get this horizontally rotating column of air. And then the updraft gets involved and takes this horizontally rotating column of air and tilts it. So it's still rotating, but now it's rotating vertically. All right, so maybe so this way. So you go from this way and you get pushed up and you're going this way. All right, and it can go either way. This can go clockwise or counterclockwise. All right, thunderstorms and supercells are not affected by the Coriolis force. All right, they're too small, even though some of these can be 5 miles across or so, or 6 miles across or something like this, they're still too small to be affected by Coriolis. So these mesocyclones, they can go either direction, and they do rotate in either direction. All right, so again, that's the formation of the mesocyclone. I'm going to show you, so the mesocyclone, again, is this vertically rotating column of air that's right in the middle. So the updraft is now rotating, which is different than your normal regular little low thunderstorm where it's just the rising air coming up. This sucker is rotating up, all right? Let me show you some pictures of what that looks like in real life, all right? It's not a fast rotation. This is not a tornado, all right? Usually the mesocyclone forms what is called a wall cloud. All right, we lost that sheet of paper. All right, so you can see these two pictures right here, which are pictures of them. All right, but you see this little part that sticks out, this big wide deal? This is the wall cloud. It's the mesocyclone. And when you watch it, and I encourage you just to go to YouTube and Google mesocyclone videos, and there'll be plenty of them on there for you to watch. You can see this rotating. Again, it's slow. It looks maybe like a merry-go-round or a carousel or something like that. It's not fast, all right? This particular picture does have a tornado on it, so you can see the difference in size between a tornado and the giant wall cloud mesocyclone, okay? Here's just another picture of it. You can see here's the mesocyclone within it. So this whole entire thing is rotating, but fairly slowly, all right? You're not going to get dizzy if you were up in that or anything like this, all right? So now these supercells are oftentimes embedded within a squall line, and they are deadly. They can be deadly. Let me show you, I'm going to show you a couple of diagrams of them. Let me see if I can find the right one. It was right here. All right, so here is one diagram of a supercell right here. These are the tallest thunderstorms you're going to see. They're still cumulonimbus clouds, all right? But these reach up the highest in the atmosphere to the point they literally pop up into the stratosphere. That's how high up they are. So they're up, way up into the upper troposphere where all the geostrophic winds are flowing, all right, which play a big role. But we still got the main parts. We have an updraft. In this case, it's just rotating. We're going to have downdrafts as well. Some of the downdrafts are going to be fueled by just the regular old rainfall that comes down just like they are in regular single cell thunderstorms. All right, so those parts are the same. While I'm at this diagram, I'm going to give you a quick idea about hail. Of course, hail is frozen water. It's ice that falls out of these types of thunderstorms. All right, but it's not the same as sleet. Remember, sleet is just a wintertime phenomenon. It's just literally frozen rain pellets that are falling out of a nimbostratus type of cloud. All right, in these really tall types of thunderstorms, what happens is you start out with a little pellet, little piece of ice frozen up here. It could be a raindrop that froze, all right, and it's falling, but then it gets caught back up in the updraft and it gets taken back up to the top. More water freezes on it, and it's gets either in the downdraft, starts to fall again, and then gets caught up again, goes through another cycle. The more cycles that little pellet of ice grows to and goes through, and the more water layers get frozen on the outside of it, and the bigger and bigger it gets, until finally it either just gets completely kicked out far enough away from the updraft that it makes it on down, or it has gotten so large that the weight of it drags it down. Basically, it's too heavy for even the updraft to hold it up. Now, certain hailstones, they can be small in size. They can be pea-size hail, just something itty-bitty little. They can go up to marble size and ping-pong size, and then like softball sized. The largest ever recorded, which are extremely rare being this big, were like almost the size of a basketball, something like, I think, 12 inches around or something like this. But they're usually, thank God, not that big. But even the small pieces can do a lot of damage. Of course, they can damage your cars, dent your cars, break windshields. If you are standing out in it, it can whack you on the head. It can damage livestock, sheep and cows that are stuck out in one of these storms, but it also damages a lot of crops as well, just literally beats them to the ground. So hail is not, nobody looks forward to hail. But if you take a hailstone, again, this is a picture that you can look up online very easily. If you slice it, it's got layers in it, just like an onion, all right? So you can, just like tree rings, you can count all the different layers of how many times it's cycled up through the updraft and downdraft, and they got cut up again and fell down and fell down. All right, so that's the hail. And that's actually pretty common in these types of thunderstorms as well. The tornadoes that form from these supercells are actually much more rare. I will talk about tornadoes in more detail in the next little set that we're gonna cover. So we're gonna kind of not talk about them too much. But this is another diagram, a little more complicated diagram. Well, it's an old book falling apart here. Let's set it down. All right. That shows you a better idea of, this is a complicated storm. All right, there's a lot going on, lots of different directions of going on. And this one, the green or green-blue, is our updraft. All right, so here's our mesocyclone that goes up here. Here you can see the wind shear. We've got the more surface winds that are blowing across this way. All right, up here we have the geostrophic winds, those upper air winds blowing this direction. So there's our wind shear that's going on. All right. Now, like I said, these lower winds that are blowing through here can end up turning into part of the downdraft, but oftentimes it's the geostrophic winds that get dragged down into rain and things like this. Now, what is different about these, and the reasons that the supercells can last for hours, is that the downdraft does not choke off the updraft, all right? And it has to do because they tend to occur in, different locations. So right in the center, you've got the updraft coming up, and then the downdraft is blowing here. Plus also, as long as these winds are sustained, we know the upper air geostrophic winds are usually blowing all the time. And so it's like an endless supply of fresh, cold air to become the downdraft right here, all right? So that's part of the reason also that these will last for so long, all right? As opposed to, again, it doesn't choke itself off near as quickly. That goes on, all right? So you don't have to know all the parts and details and everything like this of a supercell. Just understand that you've got to have that mesocyclone, which is formed by wind shear, and that these guys can last for hours, and they're very large storms. But again, oftentimes embedded within the squall lines that we see here all the time, okay? And usually the spring and the fall, when we've got the bigger temperature differences between the Canadian, the cold Canadian air and the warmer Gulf air, all right? That's when we get the more intense storms and squall lines that form up with those passing mid-latitude cyclones and the cold fronts that accompany them, all right? So is this making, hopefully this is making enough sense for you guys. So let me tell you, let's go ahead and talk about tornadoes while we are here, all right? So tornadoes, as I said, are birthed from supercells, but most supercells do not form a tornado, all right? We still don't exactly know what the trigger is, what makes one supercell birth tornadoes and then makes the other 20 not, all right? We still haven't quite figured that out. But tornadoes, let me show you how those guys form. These are extreme winds, all right? Now, speaking of extreme winds, I need to take a step back because I know of something I forgot to tell you guys about, and that was the microburst, okay? Which microbursts can occur in supercells as well. They can actually occur in any thunderstorm, all right? So let's go back to the gust front for just a minute. So let me show you another diagram of a gust front, all right? If I can find it. Okay, so here we go. So let's talk about the gust front for a second. So here's a good diagram of a gust front. So again, you have your normal downdraft, all right? And it hits the ground and it's gonna spread out. Just like if you're pouring pancake syrup, down, it's gonna spread out all over, all right? And you have your typical little gust fronts. And like I said, most of these are just, I don't know, 15, 20 miles per hour, something like that. It's gusty, but no damage. But every now and then, you will get what is called a microburst. This is a super, super strong downdraft where the air just plummets down, sometimes up to even 100, 120 miles an hour. And of course, when it hits and spreads out, you've got regular horizontal winds blowing 100 miles an hour. This is literally hurricane strength winds. That can do a lot of damage. Now, the microbursts are usually very small areas. Maybe a mile area is about all it will affect. But if you've ever been caught in one, I've been caught in at least 2 in my lifetime. It's not pleasant. I mean, it's just, you've got a thunderstorm going on outside and all of a sudden all the trees are bent horizontal or blowing over or being pulled up, and it's just crazy. The one that I remember the most, this was way back in the 70s, and it was in the summer. We were watching, I remember the Summer Olympics. It was some of the races were on. And it was a storm out, and we looked out, and my dad had planted some just, fairly new saplings. And all of a sudden, those suckers were literally bending over like this. And, he thought they were going to snap and break off. And I remember him yelling at the wind, stop, quit it. And it was really scary. But then it went completely dead. All right? They straightened up. There was hardly any wind at all. And then the wind came from the opposite direction. All right? And flew over this way. Again, for about 5 minutes this way. And so obviously, we were literally right in the dead center of that when it went through, when the downburst or when the microburst happened. And it, so it blew from this direction. Then as it passed, then we got the winds going from the opposite direction. And Yeah, it was pretty scary. Now, on pause, under announcements, you will see that I have added some suggested videos for you guys to watch. Listed on that are 2 short little videos of microbursts of what it actually looks like. One's to be inside of one where it's happening, and another one is taken from a distance so you can see the whole thing happening. I think it's over Phoenix is what it is, or something like this. So be sure to watch those. They'll give you a much better idea of what the micro bursts are. All right. So again, those can occur in any thunderstorm. They're pretty rare. They don't, like I said, that I've known of, I've been in 2 my whole life is all 2, maybe 3, you know, and I've been around a long time. So they're not super duper common. All right. All right, so let's go back to tornadoes. Tornadoes are not microbursts, okay? Tornadoes are even faster. Tornadoes are the fastest winds on the planet, all right? And again, birthed out of supercells. So in order to have a tornado, you have to have wind shear, all right? And it's the same wind shear, I'll put this here so you guys can see this. The same wind shear that is gonna form the supercell in the first place is going to play a role in tornado formation. All right, so you've got more wind shear going on that goes on, okay? And this time, so you know, you've got some of those horizontally rotating column, or no, it's not even really a column, but a horizontally tube of air, okay, rotating. But in the tornado's case, it's the downdraft that blows that down, all right, to make the vertical rotating, all right? So it's different from the mesocyclone in the sense that the mesocyclone initially forms because it's pushed up by the updraft. But here, you've got rotating columns of air thanks to some more wind shear that gets pushed down, all right? And again, these guys can travel clockwise or counterclockwise. They can spin either way. It's not reliant on the Coriolis force at all. Has no bearing on it. But this is showing right here, all right, how it's pushing down on the column of air, and it gets attached. And oftentimes, you'll have like 2. You can have multiple vortexes at one time, all right? Or you can start out as multiple vortexes, and they actually combine into a much wider tornadoes. Tornadoes can be anywhere from a few hundred feet apart or wide to over a mile wide. They're big, they're little, they're skinny, they're fat, all right? They can, of course, the tornado itself is just spinning wind, and the wind can get up to probably at least 300 miles an hour. We actually don't know exactly how fast it can get, but it's those extreme speeds that are the problem. Now, the big danger with the tornadoes is actually, believe it or not the wind per se. It is projectiles that are being pushed through the wind. I have literally seen pictures of I brought one in here. Now I can't find what I did with it. But imagine a pencil, all right, that is embedded into a tree, all right? That's what 300-mile-an-hour winds can do. It can take something very, little like a pencil or even a piece, a straw, and embed it inside of trees. I have seen a 2x4 embedded through a concrete wall. All right, I've seen pictures of that. You can look all these up online, examples of this. So that's the problem. It's not the wind per se. Now, tornadoes, again, moving up to 300 miles an hour, they can pick you up, all right? Again, that's not what hurts you. What hurts you is going to be if you're picked up high in the air and then you get out of the tornado and you fall down. And it's that sudden stop at the end that will do damage, all right? But that's usually one of the things that's going on. with tornadoes. Now, lucky us, all right, let me pull, I got a picture here somewhere. Now, our tornadoes can occur all over the world, all right? However, lucky us here in the U.S., all right? Remember we talked about the uniqueness of our big old battle zone. The fact that we've got this huge, wide open area that is not blocked off by any east to west running mountains. But we've got all this wide open space for the cold Canadian air to meet up with the warm air from the Gulf down here. All right, so we get more intense mid-latitude cyclones forming here than any other place on the planet. We also get the most supercell formation of anywhere in the planet. And therefore we get the most tornadoes of any other location on the planet. We average up to about 1,000 tornadoes a year here in the United States. And most of them are in this area right through here. It's known as Tornado Alley. Okay, but any of this, pretty much of this area right here, that's that light green color, will get tornadoes. All right? All right. And up here in New England, they happen, but they're still pretty rare. They happen occasionally, very rarely up here at Pacific Northwest. I don't even know. I don't think I've hardly ever heard of any occurring in California. They got earthquakes and other stuff to worry about there. You know, there might be one or two. But as we know, we've had multiple ones already, you know, even just this year that have occurred here. We get them in Memphis several times. On the videos for you to watch is some video from the Jonesboro one that was just a couple of weeks ago or last week or whenever, not long ago at all. All right, so you can see how that looks on that type of thing. So again, yes, they occur in other places in the world, but here in the U.S., lucky us, woohoo, we get, like I say, average of 1,000 a year. All right, so we need, you need to be aware of what you do. Take warnings seriously. If you hear those when the sirens that go off and stuff like this, make sure wherever you live, you have a place of shelter. You want to be inside the house or something like this. You want to be, if you've got a basement, go there. Not most of us don't have basements though, but be in the bottom level if you can. If you've got a stairwell, get in the nook of the stairwell is a good place. Last but not least, in your bathroom, an internal bathroom, but just any bathroom down in the tub is also a good place. But you want to be somewhere toward the center. And again, the important thing is going to, the wind's not going to hurt you. It's all, the walls falling on you and bricks falling on you and things like that. So you want to try and protect yourself from that more than anything. Grab some pillows, grab some, quilts and blankets to put over your head to act as a shelter and, try to keep some of this stuff off. I remember people always used to be talking about, go get the mattress and put that over you. Well, that's fine and dandy, but you know how heavy a mattress is? You ever try to, take a queen size mattress and drag it off the bed? There's, so don't mess with that, Like I said, just grab some pillows or something like this and huddle down in an enclosed closet or something like this. New fellow that started at work who's from Pennsylvania, we were, literally telling him, yeah, dude, you need to, I know you're living in an apartment building, but you have to find a place. My cousin, who used to live up here in Washington and now lives right outside of Little Rock, one of the first things she did was build one of those underground shelters, and she's had to use it multiple times. She's never been hit directly, but they've had some that are close by all the time. So yeah, don't stand out and take videos of it. And yes, the videos are cruel, and again, you can see lots of videos. I've posted some of my favorites that give you a good idea of what it's like to be in a tornado. But you can, if you want to, you can spend hours online looking at pictures of tornadoes, and I encourage you to do that. But just if you don't have a lot of time, look at the ones that I've given you the link to what it's like. But take them seriously. Don't don't put your safety at risk to try to get a cool photo of these. Get yourself to safety. All right. That's the main thing to do, because we do have to worry about those. All right. So I'm going to take a quick break here. So I'm going to stop this, and then next up we're going to be talking about lightning. All right, which is going to be, of course, a issue with any type of thunderstorm. Okay, not just supercells, but all thunderstorms. We'll see about lightning. So let me take a quick break, and you guys can take a break and come back to that.